Hello and welcome to this new edition of the Foojay Podcast. In this episode, we talk about testing. How do we make our code reliable and what is a good test strategy?
Welcome to the Foojay Podcast, all your news about OpenJDK.
As a developer, we all want to write bug-free and high-quality code. Writing tests is a crucial part to achieve this. Let's explore the art of ensuring robust and bug-free code in the Java ecosystem. Whether you're a seasoned developer or just starting out, there's a lot you can learn from the experts in this podcast about testing methodologies, tools, and best practices, all empowering you to write reliable Java applications.
My name is Roni, and I'm the founder of Digma AI, which is a free IntelliJIDEA plugin for continuous feedback in dev and test. And I've been kind of working as a developer and struggling with many of the questions that we're talking and we'll talk about today for almost 25 years. So I come both with answers and questions, maybe more the latter than the first, but we'll discover more of that during the talk.
Hello everyone, I'm Jonas, I'm a software developer, and I met Frank and Ronnie at the local JUG where I gave a talk on testing, the same one I gave on DevOps last year. I also dipped my toes into blogging last year around the subject of testing, and that is, I guess, why I'm invited in this podcast.
Hi, my name is Oleg, and I work as a developer advocate at Docker. I work on the Testcontainers project, and it was a part of a recent acquisition by Docker of the Atomic George startup. I was a developer a long time ago, and then I converted to the marketing side of things. But being exposed to Testcontainers and working with community, I think I can contribute something to the discussion on the testing practices.
And I'm Frank Delporte, a Java developer since over 10 years and documentation writer for Azul, also the producer of this Foojay podcast to learn everything which can be learned about Java and its ecosystem and all the tools that are available for it. Okay, where do we start with testing? Maybe the testing pyramid? Is that something where we can start with? Because I think it's known to a lot of developers as the basic of a testing strategy, but is it still correct?
It might be time to reconsider it. And the reason that I say that is that technology landscape is not as it used to be. It's kind of like configuration management. You know, when we had big, large servers, we had to invest a lot in the puppets and the chefs and all of these config management tools because infrastructure was costly in terms not just of price, but of time. And there was no real option to just spin up a server on the fly with to work with immutable infrastructure. And therefore, we all invested a lot in config management tools. It seems that today with containers, test containers, and in general, I would say the friendliness and kind of support within the frameworks for testing, the cost of spinning up more complex tests has reduced dramatically. So in the same way that we can afford to let go of config management today and work with immutable infrastructure in a much simplified way, working with or starting an integration test today is not what it used to be. And for me as a developer, that means that if I need to make the trade-off between writing a very thin unit test that will test maybe logic or very specific narrow logic and writing an integration test that can test more along the way, punch for the bucks today, it's not, I would often choose the integration test, which completely goes against the 80% unit test paradigm of the testing pyramid.
Jonas, in your presentation that you gave also at our BJUG, you took another approach. So you have, instead of that pyramid with the unit tests at the bottom and then service tests and integration tests on top of it, you have a different way of visualization, the test strategy. What is a better approach according to you?
Better, I'm not sure, but different for sure. First, I didn't come up with the approach, but it's called the testing Honeycomb. I think it came out of Spotify Labs, and it's basically it's not a pyramid anymore, but it also consists out of 3 layers. And the main layer is not the unit test. It says you need to focus on behavior, and to a lesser extent to implementation details, and to an equal less extent to integrated tests. But before we dive into that, I think it's interesting to talk a bit more about what Roni said, because it's indeed something I noticed. The technical frameworks and infrastructure around the way we write tests has dramatically changed, but also the way and the type of applications we write today. In the past, I used to work a lot on big monoliths with a big domain and everything was inside. Today, the landscape on my current project consists out of, I think, about 15 microservices. And if I look at those services, the domain aspect of a single service has become thinner, whereas the integration aspect, the adapter layer in a hexagonal terms, has become bigger and more important. A lot of these services are just basically transforming data. So there's a shift going on there that's also helped us move away from the testing pyramid.
Is there also a big influence of test containers in this change of how we test things?
And I would be very glad to say that yes, test containers, of course, kind of spearheaded a part of this migration by giving developers API to do things in containers much simpler, and integrating both with testing libraries and frameworks to simplify connections, right? But also with the application frameworks to simplify it on a larger, sort of service scale, right? If you write an application and you have the full support out of it, then of course it will be easier for you to adopt the approach. And yeah, indeed, I think this transition of the mental model from like a testing pyramid to a honeycomb, we very often advocate for when we talk about why test containers is such a great library, because it allows you to create tests at a higher level. But in general, if we take a step back from just thinking about in pure theoretical terms, right? Because this is like a testing pyramid or honeycomb. It's an abstraction, right? It's sort of a guidance system where we would say like, oh, I think I should maybe have more tests, or maybe I should have tests, and that there is a question, right? What sort of tests do you want to have? And as a developer, it's very easy to have a card with an answer. Oh, I need unit tests for these components. I need the integration tests for that. But in reality, I think there are very many discussions online, but I feel lately, in general, there is very little duality between those, right? The unit test, the term was coined many years ago, right? And then the unit is originally a unit of computation. It doesn't necessarily correspond to a particular class or a particular like language construct, or even a component of the system, right? It can be anything. You can call a unit like the whole subsystem or your whole application. So through the years, maybe historically we were taught, maybe by academia, maybe by just how the industry turned out, we were taught that unit tests should focus on like individual methods, or maybe individual classes at most, and you test this internal computation that is happening. But originally the idea was just to take a slice of your system, right? Call it a unit, run it. And then integration test is now when we say like an integration test, when multiple components of the system are involved, right? When we talk about test containers approach, that is your application and then services around your database, maybe mocks of your other services, maybe your message broker and so on. But it could be just components of your system that normally don't, that are written in different ways, right? Say a just-in-time compiler and a garbage collector. You can unit test just-in-time compiler just fine, but it needs to be aware of the garbage collector, and it needs to, like, for example, meet some barriers or do some changes, things differently depending on that. So you want to test a combination of those. And that's sort of like, you can call that an integration test because it doesn't test components in isolation. But say for a normal Java developer, would you make a distinction between a JIT compiler and a garbage collector being different components or not? It's unclear. When I'm writing a Spring application, 200 stack traces levels above main, it's not a dig at Spring. It's just like with a very high level abstraction, right? I don't differentiate between JIT and GC. I just say it's my JVM. So in my opinion, this is something that I've always, not always, for a number of years now, tried to kind of ask people. So imagine you have an axis of tests, and on one hand you have unit test, right? And you can see it, and you say like, yes, this is, we're testing like an addition method a plus b, both integers. It's clearly a unit test, right? And on the other hand, something that is clearly an integration test, right? It spins up multiple processes. It like gets you a database, a cluster of Kafkas, hopefully with test containers because it's convenient, right? So we would like, but any developer would look at that and say, that is integration test, right? Where is this distinction? Where is the border? Where is like, so, and then the complexity sort of rises, right, from one to another. But can you say that at a certain point, right, there is a switch? I would argue that you absolutely cannot.
I think this is the fault of conventions, because similar to the way we kind of fell into the convention, I remember with when ORMs came into being, it was all about CRUD. You have to have add, or, people were talking about resources in HTTP, and it was, no, resources have to be CRUD. And in the same way with testing, you had a method, you had a test method, you had a controller, you had a test for that controller.
Controller test, yeah.
And it became almost ceremonial rather than about anything that had to do with where the logic is. And because of that, we ended up, because of the template almost, I feel that we ended up, as you say, that it was very superficial because it was very template based, and people would use generators and would get the scaffold of these folders, and it would say, well, I added a method, I have to have a test with the name of the method. I remember following that practice even, and even then it made no sense. And I think what, for me, was a little helpful in getting us out of this, I would argue, anti-pattern of thinking about code as in any way significant in defining your test plan, the code and its structure, was BDD. Because I think when BDD came along, suddenly we got familiar with the concept of outside in and thinking about the behavior of the system. And it introduced better practices through semantic conventions like adding should at the name of your test. And again, it's just one way to do it, but what it helped developers do, what it helped me do, was to think about what is the behavior that I'm testing rather than which class am I testing or which method and so on. So, and I think you're spot on about the maybe false dichotomy between unit and integration test. I would argue that if you have a very complex scientific calculator that you're testing, even though it's just code and it doesn't have any containers or services, the setup of the environment to test it might be extremely complex, even though it doesn't fall into kind of the definition of integration test. It might be just as complex to set up, and you might have single service integration tests that today, for example, with tools like Testcontainers that make it very easy to do, just add an annotation and you have a working server. So why is that now not a unit test? So I think the fact that the definitions are becoming blurry is a good sign, because it's kind of dragging us out of this set of assumptions that we were kind of victim to about a very templatized way to think about testing.
I think also probably code coverage tools forced a lot of developers into, let's just make a test to test this method so it is covered, but indeed it doesn't fit in your business model. That's a bit the story you also have in your talk, Jonas. Already the name of the test is a completely different approach that you have taken.
Yes, indeed. I try always to focus on the behavior that I'm trying to test. Most of us developers, we don't write frameworks. We write applications for businesses, and there's clear behavior to be written and hence to be tested. And I see a lot of developers, and I've done it myself because that's how we've been taught to focus on the code, to test the code. And what do? You start with unit testing. You mock out all dependencies. That's what you get taught. And then you have 100% or 90% code coverage in best case. And then you're a good developer. And I've worked on many of those projects, and I thought we were doing good until we had to refactor things. But the behavior didn't change. Business didn't come to us and said like, this needs to change. No, it was us. We were driving technical refactorings. And what happened is I noticed quickly that a lot of these tests were worthless. I didn't feel safe anymore in a way as a developer, because I had to delete and rewrite a lot of tests because the dependencies that I mocked out changed. And when I started to realize that, I thought that took me a while actually to actually stand up and say, like, I think we're doing something wrong, because everyone is doing it around me. So now I like to think that when you explicitly test behavior, you're going to implicitly test almost all of your code, because else there's behavior that's not used. And the only cases that I've found in my current code bases is like when you need to catch a checked exception or something like that. And it's very hard to test from a behavior point of view. And on the other hand, I also think that you cannot test an application only by testing behavior. Sometimes you need to test implementation details. And what is the difference between an implementation detail and a behavior? Sometimes it's very clear, but sometimes it's a very gray zone. There's no dividing line. That's also something I think is not 100% correct even in the testing honeycomb, because they draw a line. I think it's more of a gradient. Sometimes we're in the gray zone. I like to avoid discussions with developers around, hey, Jonas, this is not really a unit test, or that should be an integration test. I don't think that's really relevant, and it adds a lot. A behavior can be implemented and tested with a unit test, or with an implementation detail test, or with an integration test. That's how you're doing things. But what you're testing, you're not testing a unit or an integration. So there's a subtle difference there. So about the implementation details, imagine when an invoice is paid that the receiver receives an email. So we got this email service interface, real Java interface inside our code base, and we make an implementation out of that. And we're using AWS, and we're using the AWS service to send emails. It's called, I think, Simple Email Service. So we we make an implementation, we call it simple email service, and if we test the behavior, we're going to say when the invoice has been paid, then an email should have been sent, and that's the behavior. That's what the business cares about. If it's been sent through AWS or not, or something else, they don't really care. The email should be sent. That's so. You can write a behavioral test for that. Just test the behavior as I just said it. And if you take that implementation, that simple email service AWS implementation, and you test it in isolation, for example, with a test container, because I think they have a local stack test container, for example, and then you're more testing the implementation detail. Because if tomorrow it turns out that AWS is too expensive, we're going to move back to our good old SMTP server that we have flying around here. The implementation changes, but the behavior does not. And if I run that behavior test, it should not fail because that email is still sent.
I would argue, though, and that's a great example, that the options here are not between testing behavior or implementation. The options here are between testing behavior and implementation, testing just the behavior, each with its own set of constraints. And I think this is maybe a great kind of point about the cost of writing tests. And maybe we can kind of slowly turn from just knocking the bad practices of the past, like old timers, and talking more about a framework for the future. And I don't think we're going to come up with very definite answers just because each project has its own definite answer. So if there was a manual, somebody would have written it by now. But I think these are useful terms to think about the problem because when I think about the tests, I think about pros and cons. And I personally feel there should also be active effort thinking about the test plan and what is our strategy around testing for each project. If you don't have a strategy, then it just becomes the last thing on your mind each time, and you kind of an afterthought. But if you do have a strategy, then the question is, in what ways do you consider or do you make the decision about which test type or which tests to write, how much, and so on? And this is a question I see repeated a lot. So I ran into this question in Reddit, and it was one of many where the person was saying, how do you approach integration tests? How much do you write? Do you cover a lot of happy paths, or do you go very deep? And there are no answers, right? Nobody says, these are the tests that you need to run. And what you mentioned just now really raises, in my mind, one of the costs when I think about testing, which is the cost of change. So I remember, like a while back, I was trying to find this comic strip for the sake of this conversation. I could not locate it. It was this. I have to find it. It was a comic. I don't remember if it was XKCD or Simply Explained or one of these amazing comics strips, online comics, and it was showing this group, and they were saying, "Yeah, we're going to accelerate development because we have tests now, and we don't have to." We don't have to do manual testing, and it's going to be much faster. And then they add more and more tests. And then, like 2 months later, this product manager says, "I want to add this feature," and the developer said, "No, we can't do it. It would break too many tests." And and I think this is kind of one parameter to think about tests, which is tests can be cement. Okay, tests can cement behavior. They can cement implementation. In the less, and you need to consider that as you write them, because if you end up spending a very long time just rebuilding your entire test suite because you added too many tests on something that was still in motion, it was still coalescing into functionality, especially in agile work, then you may have either introduced the tests too early, or you spent a lot of time covering or working on things that are maybe not mature enough to have these types of tests. And I think this is kind of one dimensionality that I think about, which is what would be the cost of tests in terms of impacting my change. But I want to open up this topic because I think it's an amazing topic, which is whether if we don't separate into, and we kind of chose the easy way out because we said, yeah, it doesn't matter, integration test, unit test, fine. But what if it does not matter, then if we have today all of these options, right? We are fortunate enough to be able to just spin up, a Spring server on with a few lines of code. We're fortunate enough to spin up Kafka or Rabbit or all of our dependencies, and we have the kind of good trouble of having too many options. So now, what should guide us as we choose our testing strategy? What are the I think one of my criticisms of the unit testing pyramid was that the axis of the unit testing pyramid, I think, to me looked a little bit off. I think it was. Let me pull that up. And so the question is, what are in this kind of decision making that we're talking about which type of technology to use, which type of test? What are the right axis for this graph? Like, how do we choose, and what are we prioritizing?
Yeah, you're totally right. That's also why my talk was called "Your tests also need some architecting," because it's something I see a lot, that a lot of senior developer architects, they really have an opinion and want to have an opinion about architecture, about the application, but that's always for the production code. And you see architects, senior devs saying, this is how we're going to layer the application. These are the boundaries. They create architectural rules through tools like Arch Unit. But then the developers are totally free to do whatever they want on the testing realm. One dev thinks, I need to write a lot of unit tests and mock everything. Another thinks, nah, maybe not. And I've opened project, and it's a mess of different styles and different opinions. It's quite interesting, actually, how on one hand, we're so focused on architecture, but on the tests, let most of it just go.
I have seen mock-up frameworks that developers hand wrote because they were facing a difficulty. And I could not believe the level of complexity and the level of effort. In some way, it was inspiring. In other ways, it was, I wanted to bang my head against the wall because somebody spent so much time thinking about this state machine mocking, where it might, this is kind of just another cost that you pay for your test if you end up with this whole shadow system that is intended to mock your original system. Other ways that I see a similar cost, again, talking about this new framework of thinking about testing, is in design for testability. And there, I think we've suffered and we've been the victim of, again, a very bad set of conceptions. I have seen projects that could be extremely simple, extremely thin, become this hodgepodge of dependencies and injections. I'm a big fan of DI, but DI everywhere becomes crazy sometimes just because they wanted to mock each service and be able to inject it. It necessitated design decisions that had a big cost in terms of abstraction. And today we know, I back in the days, sorry for sounding like an old geezer again, abstraction was all the rage. The more abstraction you had, the more sophisticated you were. Like, what do you mean? I remember doing that in interview questions. Candidates would come in and I would ask questions, and the answer was always dependency injection. That was the answer. And if they couldn't think about that, then they weren't sophisticated enough. And today, we know to also favor simpler designs that don't have that cost of abstraction, where it's very clear what's going to happen when this code is being called. And testing and design for testability was often colliding with simplicity. It was making you, because you were looking at the internals of the code, it was making you make changes. And I think in that sense, what test containers are helping us do, test containers and any technology that allows us to kind of think, create all of our dependencies from the outside rather than starting to inject services and create interfaces around everything, along with other tools within Spring and within other frameworks, is just, it allows us to not spend so much time just working to change our architecture just so we'll be able to test it and not change it for the better. So I think another, if we're kind of thinking about the new lay of the land in testing, so another dimensionality for me for testing is, what is their cost in terms of my architecture? So do I need to make my system worse just to support this use case called testing? And sometimes it's worth it, sometimes it's not.
The whole mocking thing, I've been doing the same thing. I've been creating monster mocks in the past. But isn't that because we didn't have tools like test containers?
It's because you didn't know about the tools like test containers.
Yeah,
It's a
probably.
it's a fairly mature old project, especially in the Java space, right? It's like 7, 8 years old, right? But yeah, very often we did mock things, and then we changed the implementation, and mocks would break, and then that's horrible. But coming back to what Roni said, right? Why are we writing tests in general, right? That's the question. Like, it's an obvious good to say that, oh, we want change to be easy, right? Like it's a true, correct statement. It's just, it is correct. It is very important. And if you forget that, you might be misguided. Right? But I think when we think about it, what it means, that tests are not just a sort of a quality assurance thing, right? We do use tests as the signal of confidence how our application behaves. Ideally, our test suite should be comprehensive and complete, right? It should, if it fails, it should mean that something is broken and we need to address that. Not something somewhere in the world is broken. Something is broken in our application we are working on, right? And that is like a lower bar to clear. Sometimes tests are flaky and everything, so it's not the easiest thing in the world, but it is a lower out of 2 bars, right? But it's also for the confidence, like thinking about tests as the quality confidence tool. The green test should mean that your application is correct, that it works, right? And then there could be non-functional requirements. For example, there could be like performance issues or I don't know, like interoperability issues or something else, right? Those are separate concerns. But your main test suite, right, should give you the answer whether the application behavior is correct. And then you want to have tests from that point of view. But as a developer, and this is what Jonas said, I think it resonates with me what you said very much, is when I, as a developer, write tests, individual tests, I'm not looking at the whole suite, right? I'm looking at the test for a particular feature or for a particular bug fix when I need to reproduce something, right? I think of tests as a developer productivity tool. I'm not trying to enumerate all the use cases that my application has to conform unless I am in a very strict environment where that is truly necessary. But then you know what you're doing and like you're fine without this podcast. But in general, right, I think I look at the test as a developer productivity tool. I want to safeguard myself from accidentally breaking other people's code. So I will run tests that are already there, assuming everyone is the same, on the same page with this. And I will also write tests that will fail if somebody would accidentally break stuff that I wrote. It for completely selfish reasons. I mean, like, I do care that the project succeeds, that we have code quality levels and so on. But my most basic motivation is that I don't want to be the one that kind of digs in the code 6 months later when somebody else breaks it by accidentally changing other components of the system, right? I want to cover enough path and enough behaviors with enough attention to detail, right? And potentially going into implementation details to know that when somebody breaks it and the tests that I'm writing will fail, that will mean my stuff is broken, right? And then it would be either on me to go and fix it, which I don't want to do, especially 6 months later, or it will be on whoever is currently working on that particular change and accidentally breaking, right? So it's a developer productivity tool to simplify change. And then I don't even think you need to like come up with a particular architecture for the test. It could be different for different projects. But the idea in my head, the ideal situation is it's very easy to add tests, right? You want the system, and probably it could be your task as an architect in a project, or maybe like very frequently nowadays platform teams. They can sort of advise certain ways of do things, right? So adding new tests for functionality should be the path of the least friction. I'm not sure if that's like, maybe it could be a catchier, more correct. The path of least resistance, right? Mm-hmm. The path of least resistance. So as a developer, I would just do that without thinking. And then me doing a thing without thinking should result in the correct thing for, say, 80% of the time, right? So I want that in my project. I want that in my company. So everyone writes tests, and then when they write tests, they will encode some business behaviors that they need to achieve. If they need to go deeper, they can go deeper. They don't have to. In the example with the email server, I would probably use local stack. I would probably use the particular implementation, and then switching providers doesn't happen willy-nilly, right? It's usually a big decision, probably will be warranted to change the test as well. I don't need to like reinvent the very high level behaviors where I register Gmail accounts and expect the emails come there, right? Which I could, right? Which is because it mimics what I would do as a manual quality assurance person, right? So, but tests as the developer productivity tool to keep my flow, to keep me in the zone. Because when I break something, right, I don't want to think about the whole system, right? I don't have capacity in my head. I'm a very average developer at best. I cannot do this, right? So I want that context of everything be externalized, right? And sometimes on the lower level, like language level, we very value this, right? We're like, ooh, this language avoids us to omit semicolons. That is amazing. I don't have to think about semicolons. And we naturally are like, yeah, this is great. And then, but it's a small thing, right? But we can see how it could benefit. It's like, yeah, sometimes I forget, or sometimes there is, or the other way around. Some people like semicolons and they're like, it gives me clarity, right? But like either way, we are like, I don't want to think about this, right? So with the tests, I don't want to think about other components. When I do something that breaks them, I want tests to tell me. I want to reduce my cognitive load so I can find a place in the code very, very easily, right? If I want to find how can I safely change, or what does the system do in a particular place as well, right? The opposite. I want to change it. I want to see which tests break, and I want to go and read the tests and see what is the behavior of like how might change sort of in a weird mutation testing way, right? Explore the system. I want that from the test suite. So, and then the quality aspect comes naturally as a major benefit, but to me as a developer, could be slightly secondary.
So
in a way, they're executable pieces of documentation.
Yeah.
You
Yeah.
don't want to be confronted with a failing test and you just simply read the test method and you have no clue what's going on. And then you have to read the whole method. And then it's hundreds of lines long in the worst case to understand
Yeah.
why it's failing.
Or just ignore the test.
Yeah.
Oh my goodness, you didn't say that.
No,
Oh my God.
bad points for Roni.
Yeah.
My pet peeve when people run tests and they start failing and they're like, ooh, this is fine. It is CI. It like always fails in CI. Let's ignore that in CI. We'll
Flaky
just run
test,
this
of
locally.
course. And
Or
that's
the
another
or the opposite.
That's another cost, by the way, flaky test. And I've often seen flaky tests just ignored. There's an intricate bit of timing or whatnot that's very hard to capture via test. And after, people get tired of this test sometimes failing. So either, if the build is sometimes red and it doesn't mean anything, then the build being red doesn't mean anything at all. And then that slowly kind of deteriorates into a situation where people start commenting out tests. I've seen that with performance tests. People just raise the bar because we hit it too often. You should always be careful about the easy path out. But I want to talk about. I love what you said, Oleg, about the personal angle of testing as a tool for developers. Because I think it takes us a little bit out of the cost side of the equation that we talked about before in terms of what is the cost of tests that you should consider to the value of tests. And here I want to both completely agree with what you said, but also challenge one of the assumptions. So I completely agree that testing from a personal perspective as a developer are a great tool to get feedback. And I think feedback is kind of at the heart of it because as I'm writing code, there are two questions that come to my mind all the time, which is the first is, what do I know about this code that I just wrote? And the second is, when do I know it? And tests are a great way to say, okay, what you know about your code, like if you think about it, what do I know about my code? I know I write a new code or I change existing behavior. I can run it in my local machine. I can maybe trigger a few things, and then I'll continue to change my code, and I will have to keep running it. And the scope of what I know is what I remember to try when I run my code. So debugging your code is a very, very poor way, a very manual way, kind of like manual testing, but worse because you don't have a lot of time for it and it's not allocated within the project. To know more about what the code that you just wrote does and how it behaves. And getting feedback is extremely important. Otherwise, you're really relying on your skills to just get it right in every possible situation for every possible scenario. I knew people who could do that. Like I knew one person in my team. He used to write code, then he would delete everything, write it again. Then he would delete everything, write it again. And the third time, it just worked. No need to test, no need to compile. He had this compiler in his head. I don't know how he did it. He was a savant. But we're not all like that. And even eventually this paradigm would fail. So the question is, if we want to get feedback and tests give us feedback, the second question is, what type of feedback can we get? And this is where I want to challenge a little bit the assumption. Because at the very basic level, yes, you could validate assumptions. You could say, yes, when I add something to the bin should have this something that I added. Classic test, right? And that's great. This is kind of like basic sanity, just to make sure, all of my assumptions about reality are still correct. We're still in business. I didn't change the nature of reality. It's really important as a developer to maintain sanity. But there's so much more. Because if you are, in fact, not just testing implementation, if you're not just testing a very narrow set of assumptions, then you can get a lot of data out of tests. And for me, everything is about data in this sense. tests are amazing piece of data. Why are they amazing pieces of data? Because it's kind of like the scientific method. You have an endless set of experimentation. Each time you try very hard to isolate all of the factors and accept the code, which is changing between iteration and iteration. And this is amazing, right? How imagine the type of intuitions we can get out of this type of experimentation, especially if I'm running my system, testing out all of the engines, sometimes in different permutations, in order to get that data. And I think in this is one of the major opportunities of testing. We'll talk later about AI, and I'm less optimistic there. But in terms of getting more out of what we have, using technology and tools that are coming in. So one aspect that I talked about earlier, which I think completely changed the testing pyramid, was cost in terms of slow. I think slowness is what the testing pyramid talked about. There is complexity, and these things change dramatically with frameworks and tools. But the other thing that is changing is the value. So we've run our tests, now what? So in the current world, the now what is green, red. But if we think about tests as sources of data, then in the new world, we can think about non-functional benefits from that. Hey, look, you have a performance regression. Hey, look, you've introduced 40 new queries. Did you mean to do that? Or did you just call a bunch of functions that called a bunch of functions that eventually created those queries? Hey, look, you introduced an n+1 in your mapping. So all of these things are things that are available in the testing data. And the more you also gravitate towards other types of tests, the more data, the more diverse data you're going to get. The question is, who looks at that data? And unfortunately, right now, it's kind of hard to convert that raw data into insights. And this is not just about testing. I think this is kind of going to be with us in the development industry for a while, where we are becoming amazingly adept at gathering more and more data. And I think like observability is a great example, because with observability today, we can get unimaginable new insights. Like before, when I asked these two questions, what do I know about my code and when do I know it? I could say, well, I know my code works, I know my test suite run, and I know that whenever it doesn't work in production, I get alarm bells. Today, it's different because the code is, OpenTelemetry, for those of you familiar with it, is very easy to enable, and it spews out massive quantities of data. Now, the question is, what can that data teach us about the system? And here is, I think, where there is an opportunity for testing to provide more benefit. And this is something that I'm experimenting with a lot, which is, how do I create a test that over time lets me know more than just about the pass-fail, which I take now for granted, but also tells me about the quality of the code. So not just a Boolean true or false, but it tells me, hey, you've made the system better. Congratulations, you've actually simplified something. This now is more efficient. You've removed a critical section. These are things that are hard to measure via pass-fail, and they're not even there for like Boolean kind of type of validation. They're there to teach you as feedback about the code, because for me, it's testing ultimately is about getting that feedback back. Otherwise, after you've gotten used to tests, without tests, you're running blind. And the more you get from tails, the more you feel blind if you don't have that type of information back.
So you're not mentioning your company name, Roni, but that's actually what you're doing with Digma. It's a plugin for IntelliJIDEA which gives you all this information. Company is called Digma.ai. You mentioned artificial intelligence. I've seen different use cases related to tests. It's giving it some piece of code and asking it for a description. That's something you can do with AI. Probably, I think IntelliJIDEA is doing a lot of AI integration into their IDE. Is write me unit tests for this code. Is that a good idea?
It depends on actually the answer to the previous question. Why are we doing this, right? Why do we want to have tests in our project, right? If you wanted to assure quality, assure the set of behaviors of your application, then I think it's a horrible idea, right? Because if you wouldn't trust the AI to write code in the first place, why would you trust AI to write a different code that would check the first code, right? So, and if you do trust AI to write code, do you also trust AI to actually write code that verifies the original code, right? And if you do, what are you doing there yourself? Right? So it's just then supposedly it's to the point where you can reduce the team dramatically, because this is what the developer does. They take sort of vague input, some external knowledge that your like environment has, and transform that into changes to the system that bring business value. So I think the first answer is horrible idea, and the second answer is I don't think we are, with the current tools at least, at the junction yet where the trust in the AI output is so high, right? So I think what we will see first is developers, or at least this is I think a more sort of conservatively sensible approach, right? Would be, I would write my tests, I would codify the expectations, and then I would be like, AI, introduce the changes, right? I have my confidence in my tests, right? I created the system, so I know that sort of in a test-driven behavior way, but not exactly. I know that is the bar to clear for quality, right? And then I would be like, yeah, do the code, right? If we think about the importance of the source code or tests, I would rank the importance of tests much higher. And this is something that historically I didn't think so very much, but like more and more examples kind of point that way, right? For example, if we talk about Java development, right, the JDK development, is the JDK the most important part of that, or tests for the JDK? And I would argue the second, right, the latter. For both some like sort of political reasons and licensing reasons, but also for the implementations, right? If you want to create a different implementation, you need tests, not just to call something Java, right, but to actually be a compatible VM. So I would venture to say that AI would help first with a less critical part of code first, and then we will get to the point where we can generate tests. So that's my take on it. I don't think we are there. I don't think it's going to be an easy path there. So I think developers are largely safe currently from the threat of being eliminated as a profession.
However, look, if you kind of see the impact that it's been having, what I've seen with many developers is that testing was kind of lots of developers don't enjoy writing tests. And the tasks that we don't enjoy doing, we often delegate. So I've seen many projects where I ask them, do you use AI? And they say, yeah, we just use them to generate tests. And there's a lot of problems with this, I think. And I don't mean to be a Luddite. Like I love technologies and I love seeing them make an impact. But I think in this case, we should always be careful of the easy way out. And in this case, if you say, "Oh man, my team lead asked me to write a bunch of tests, so let me have ChatGPT do it," and they end up kind of looking nice, then I'm done. But there are multiple problems with this approach. The first problem is that these tests, and I don't know, Jonas, have you had a chance to generate tests with AI yet?
All developers have made an attempt, and it's
Were
not
you
there
happy
yet.
were you happy with the result?
No, absolutely not. But I did use it a couple of times to get rid of the toil of my job. When I knew the answer, and it was basically just typing,
Mhm.
and I could give the AI system an example of what I wanted, then there's value in there because I knew the answer up front. It's
Mhm.
just typing work. It was a lot of typing. I had a happy pod test, and I knew I needed 5 edge cases that I wanted to test. That's a lot of copy pasting, and I just described my problem, gave the happy pod test, and he gave me some good feedback that I could quickly reuse.
What could have been a parameterized JUnit test, you threw a GPT at it.
I think that there is something tempting in using AI for that because for some developers it looks like a menial task. The one problem that I had was that it did it wrong. It did not, consider any of the practices we just talked about. It was more like the old test method approach, unless you directed it to do otherwise, like method to test a mapping. But let's say they fix all of that. The tool matures and it does bring you good insights or good tests. The problem is that the process of mentally, as a developer, thinking about tests is important by itself. So defining your assumptions, defining your behavior is important for me to go through. And in that sense, my usage of AI, like other fields, by the way, as well, is kind of like to break my writer's block or to get different perspectives. I like to throw something at it and say, describe the behavior via test. And maybe I don't agree with that, but at least it gives me maybe some dimensionalities of the behavior that I did not think to test at all. Um, uh, so this is kind of taking the backwards engineering approach reverse engineering approach where you take something and you ask it to describe it, which can be useful. Um, the other aspect is if you do ask it to generate some tests, there is no way in the world you're just going to check in that code, right? There is no way in the world that you're not going to be mentally familiar with these and that they don't describe the world in a way that you understand and agree with. And I think this is kind of where there is a lot of thinking that has to be done that tests encourage, and this just highlights the fact that it's very hard to do without those thinking without that thinking, because eventually when that test failed and you look at that test and you say, I didn't even know that this was supposed to be the behavior, then you're in kind of double the trouble because you may have inadvertently had a green test but the wrong behavior. And this kind of reminds me of the what does it mean that the tests are green? Or why do we need green tests for a dilemma? Which is, if the test is green, does that mean the application is working? And and the answer is, of course, no. It does not mean that at all. Everybody can write a green test. It's the most easy thing to do in the world. So if the goal was to have a green test, it's not a challenge. The problem is, are the tests accurately describing our intention? And in that sense, we have to be involved. So it doesn't matter if we get a scaffolding generated by AI or not, as long as it follows the right conventions, I'm all for it. Like if it's actually creating a good starter kit for us to do the rest of the work, if it knows how to, I don't know, I always forget like which annotations to add in which order or what to do. Like it's like it helps, but it doesn't replace the thinking, because ultimately this is what you're validating and you're supposed to know what it is. So I think there is a piece there that cannot be easily replaced by AI just yet.
You mentioned at some point most developers don't like to write tests. I think that means that there is actually a problem with your job that you're doing. I like the test because it proves that what I just did is correct, or it shows me that I forgot to do something. So it's, and also Jonas mentioned, a test is also documentation. It tells you how the application should behave for certain use cases. So if you don't like writing the test, then maybe you should think about how your project is architected, like Jonas said, how the tests are architected, the tools you're using, or you're using the right tools. So I think if you don't like your tests, then it reveals some problems in your project, correct?
Yeah, I think you don't like that project at all. If writing a test is a chore, then working on that code base is a chore. Like in general, like I cannot imagine like a system where you'd be like, oh, it's so hard to write a test, but then you'd be like, but I'm gonna go in the deep depths of this code and randomly change things there, and that would make me happy and productive, right? Absolutely no, right? That would be even bigger problem.
I have a confession. As somebody who wrote test frameworks in the past for different tools we worked on, as somebody who worked extensively on testing, I don't like to write tests. It's not that I hate it; it's the least favorite part of my job.
Yeah,
Like
else.
when I'm, and it's not that I don't write tests. It's just that, but I confess that it's not my favorite part. Like after I'm all in working on this really interesting feature. I figured out everything. I'm working. The last thing I need is to stop what I'm doing or even and start fiddling around with test infrastructure to get it set up and working the way that I want. It's not that I don't believe in it. I'm a firm believer, and it's not that I don't practice it. But personally, it's just not my favorite type of thing to do. So
You should start with it.
I don't get that.
You should write the test first.
No, not
Yeah,
always.
yeah.
By the way, maybe that's another assumption to think about. Like, I know that many people believe that tests should be written first. For me, it's not always a good approach, and I'll explain why. Sometimes I do it, especially when I'm describing a very high-level behavior, and it's kind of very, and in that case, it sometimes makes sense. But sometimes, as I'm developing, it's where I'm a believer in kind of this maybe micro lean approach to development, where you need to work through the problem before you can start working through the solution. And working through the problem often doesn't require changing a lot of tests. It's for me, working with the code and testing it out kind of in a sandbox mode until it's just right. And in that scenario, I don't always go and update the test and update the code and update the test and update the code. So I don't always write the test first, for me at least, and this sounds maybe a little heretical. It's also not the favorite part of the job, but having said that, don't you dare not write tests, and don't you dare not think about that aspect, because that's what's keeping you sane. That's what's grounding me as a developer. The fact that I'm getting feedback about what I'm doing. So I was absolutely ecstatic about the fact that I don't need to spend as much time on tests, that I don't need to work as I did in the past about setting up the test environment so much that, but you know, as I mentioned, all of that, I still do a lot of works for test infrastructure. I still build factories in order to create, as much as possible using my own API so that it's not as brittle, but I create the entities that are going to participate in the testing. I formulate these assumptions and experiments. It's just that personally, I love kind of being in sandbox mode more.
Personally, if you have tests in the same pull request without your reviewer asking where are the tests, you were doing test-driven development by me. You weren't test-driven enough. I think it differs very much application to application, or like sort of application type to application type, Roni. So what are you saying? If I'm working on a more mature code base and I'm introducing changes, right, then usually that means that there are already an existing behavior that needs to be adjusted in some way. That means that there are also existing tests where I can take inspiration for isolating the smaller bit that I need to change, right? If it's a bug fix or a maintenance thing, then starting with the test just makes sense. You want to reproduce the current behavior, understand the inputs, map them to the actions to see the whatever errors or the behavior you want to fix or change, right? So there it's a natural place to start with a test. You can, of course, start not with a test by exploring your application first, right? But before you start doing code changes, it makes sense to kind of sort of codify the assumptions, right, and behavior. So their test comes first naturally. And, well, it's hard to say that whether this is my favorite part or not, but it's just a very natural part of the job that where, like, I don't like when I think about this development process, right? I think of tests as a developer productivity tool. I don't think about them. So, this DevOps like cycle, infinite loop, right? I think it's very much misleading in a sense, because it has built like code and build and test phases separately, right? And that test phase there, it actually signifies sort of like a CI environment, this higher level non-development kind of standard, right? Like the single source of truth for the quality. And then you normally do that before it goes to the outer loops of like development process, right? But sort of what the inner loop looks like to me as a developer, it's not this one part of the DevOps cycle, right? Because like I don't very often I don't do the whole thing: code, build, test, commit, right? When I do code, I run the tests. This is my cycle. I want immediate feedback. I want to be in the flow. I want to be in the zone doing changes. And there, writing tests and writing code, changing code, exploring what will happen when I change this, right? What are the implications? Does it suddenly change my application to go to the database like 700,000 times, right? That sort of like I don't separate that in the separate thing, right? So when you think about this, I'm gonna write code, and then when it's all ready, I polished it. It's ready to go to production, right? It's ready to go into commit. It's like fully, yes, I'm done. And then you're like, I need to write tests. Then of course it feels like a chore.
In that case, Oleg, then you already wrote the implementation, and you kind of know your test will be driven towards what you just implemented 5 an hour ago or minutes ago. But if you write your test first, it's a totally different world, because you have no implementation. You need to think, what is it actually that I need to implement? So how is this going to behave? What are the parameters? What's the input? What is the expected output? When is it correct? When is it not correct?
That's why it goes hand in hand. You write it like you don't ship your first prototype normally.
I just don't want us to get into this assumption that all developers, first of all, that writing tests first is a must. And second, that most developers enjoy writing tests, because I don't think that's a good assumption.
No, that's not. I think most developers don't.
Yeah, and I think we need to kind of acknowledge that. And I'm no different. Like I love writing code more than I love writing tests. Does that mean that I will not write tests? No, it does not. And at the same time, I think that we need to consider that we need to support or like it's very easy to get, and I had this issue with TDD advocates, and TDD. I met some TDD guys that were pretty fanatical about it at the time, and they were doing TDD at the micro level. So they were like, every little thing, every function needs to start with a test, and if you think about the gap between like how much runway you've had with your implementation versus how much time it takes for you to catch up with a test for each change, they ended up with suites of tests that I recommended they throw away. Like most of them were too brittle, were too dependent on implementation. Um, I've seen, and there are so many ways to get this wrong, especially if you don't understand or don't keep that perspective that the behavior and the outside matters more than the inside. And what they would have is they would have the same functionality, like um, the same code basically written twice, essentially. When you examine the test, following this very prescriptive process of writing tests first, they would have the code once in the test and twice in the inside the application implementation itself, and it was the same code. And if they had a bug, it just writing something twice doesn't protect you from having a bug, especially if it's an implementation detail. So what I'm trying to say is that I completely understand, and that some developers might prefer to be very uh, let's say disciplined about writing tests in a very specific way and manner, and maybe it's the even more correct approach. But realistically, many of us are going to look at tests as something that is valuable, but not necessarily our favorite part of the job. Uh, and to make that still happen, we need to set to have these ground rules about which types of tests do I need? Because if I don't have that, then I'm doing tests. And again, I don't want to come off as being too, yeah, of course, everybody has to be perfect. No, we're not perfect. And I'm sure there are many developers that complete their pull request and then they say, oh man, I have these tests to write, as you said. Or maybe they wrote some tests first and then they got carried away in the inspiration of writing code and they didn't come back to the test until the very end. And so it remains the question of what do the tests that I include in the pull request, what is their function? What do I need to get from them as a developer? And this is exactly the type of value that we're talking about now. So if I can get from the test more confidence in my pull request, if I can know that I'm not ruining something that I did not anticipate, then they serve an actual function to me rather than be a ceremony. Like if I actually got insights out of the test. And the insights can be codifying my assumption, which is to me is the least part of the job because it's important. It's great for keeping a track of changes and from kind of making changes possible. But at the same time, if I got more information out of them, if I were able to know, okay, I was introducing this new function, and as I was doing that, the test helped me find issues that would otherwise I would have found in integration and later states of the build in production. Then I get something out of it that's very tangible. And ultimately, many of us are kind of, especially when we're on a crunch, when there are releases, when people are pushing us, we're self-serving. We want to do what we can do just to be able to move on to the next task. And in that sense, it's only by connecting developers to the real value that they get from testing that it makes it worthwhile from them. And I'm saying that because I've been struggling with this. I've been talking to developers who said, okay, it doesn't matter if they wrote their tests first or not. We have a set of tests, we have the code, we're ready. What did you learn from the test? I don't know. I saw this, so I wrote this. I copy pasted another test. I changed the name a little bit. Um, and it was basically the same. So now I have this test. It's going to run and it's going to be green on the next build. Now, what I just described is insanely hard to prevent from happening at projects at scale, from people kind of taking that approach. Because if tests become, especially when the test project is mature, and it's really just a matter of copy pasting another test method and changing a couple of things, and you have another green test to show for as a trophy, then you've missed the purpose, but it's very hard to fine tune towards what the purpose is. So unless I get actual value out of the test, beyond just saying, should blah, 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 and then seeing that turn green, then it's hard to pinpoint exactly how much test and which test to write.
When you say test like this, right, I think a part of, I don't know if this is a subconscious bias or you sort of on purpose try to phrase this. There is no dichotomy. There is no dichotomy between code and test. Tests is code, right? So when you say how do I know what type of test to write, right? How do you know what type of code to write? How do you know that you need to use a factory here or an interface here? How do you know that in a certain junction of your application, abstraction is necessary, or maybe you don't need abstraction there, right? It's your experience, it's your knowledge as a developer talking. The same. Tests are code. How do you know that you can copy paste a certain test, change values, and that test gives you confidence that whatever new functionality is created, that's your worth as a developer. Right? Test a code. When you're in a rush and somebody comes to you and says like, "Ooh, like you don't need tests, just ship it," right? You stand your ground. Be like, I cannot ship incomplete code. Why is it incomplete? Because tests are missing. Tests are essential part of the code.
What is the definition of complete?
That's what you define as a developer. Right?
Exactly.
You sign off on that. If you have performance in your definition, right, in your spec requirement, right, you better have a performance test. You better have some sort. It doesn't have to be like a benchmark setup. It could be extrapolating performance from a few sample runs of other tests or something, right? But like you better have the data.
I want to echo something here, and this is really important. This line is not clear to anybody. So when people ask on Reddit, how much test is enough? Do I need to follow just the happy path? How many of the edge cases should I cover in testing? They are right, because testing can be an opportunity and it can be a rabbit hole. And as a rabbit hole, I can very easily spend infinite amount of time making the test more and more complex, because reality is very, it doesn't come in straight lines. And as a result of that, there are many ways to wrap around it with tests. So as opposed to stories that always have a beginning and an end in the way that they're defined, testing, if you ask me, giving a set of spec which test to run, I can give you 3 developers who would have completely different approaches on how much tests to write. And I want to help get the right definition, because or even the tools to make that call, because if we don't have that, then the problem is that we end up with whatever time we had at the time. Sometimes can dictate to a developer how much to invest in that. And this is why I think testing strategies are important, because we need to understand what is our goal in creating our test. When do we know that we're done?
That's a good point. Not disagreeing. Can I just lighten the atmosphere with a joke?
Yeah.
Right. Just to finish this off. So the consultant comes to the team and they're like, "Oh, I think test-driven development could help you guys a lot," right? So remember, you write the test, you see it fail, then you make code to pass the test, and then you refactor the code to be beautiful and optimize performance and so on. So remember, red, green, refactor. Red, green, refactor. Clear, clear. In 2 weeks, they come back to the team and they're like, "How's your TDD, right? How's your test-driven development?" And the team is like, "Yeah, we're doing it. This is great. The only issue is we never get to refactoring part." Right? And the coach is like, "Why is that? How come is that?" "Well, because when the tests pass, our definition of done is met."
That's a nice one, yes, a nice one to conclude. Thank you for your time. Thank you for joining this podcast. Definitely a topic we should come back to, because there's a lot of open discussions and open questions here of what is a good test, what is a good test strategy. Thanks for your time. Thanks also to the listeners of the podcast. Keep an eye on Foojay for future articles about development and everything related to the Java world. Thanks for listening.
Give me a foo, give me a J, give me the friends of OpenJDK.